We continue with the Poisson experiment. Like a binomial experiment, a Poisson experiment has four defining characteristic properties. Again, the number of successes that occur in an interval is independent of the number of successes that occur in any other interval. The probability of a success in an interval is the same for all equal-sized intervals. 3. The probability of a success is proportional to the size of the interval. 4. The probability of more than one success in an interval approaches 0 as the interval becomes smaller. Poisson random variable is the number of successes that occur in a period of time or an interval of space in a Poisson experiment. Example, on average 96 trucks, success is 96, arrive at a border crossing every hour. Every hour is a time period. Example, a number of typographic errors in a new textbook averages 1.5 per 100 pages. That's the interval. 1.5 can be regarded as successes. And here's the formula. The probability that a Poisson random variable assumes a value of x is given by P of x is equal to e to the minus mu. Mu is the mean number of successes in the interval times mu of x, mu to the power x, over x factorial for x taking values 0, 1, 2, 3, etc. Mu is the mean number of successes again in the interval, and e is the natural logarithm base. For your information, just in passing, the expected value of a Poisson variable is equal to the variance, which is equal to the mean. The mean and the variance are the same. Example, the number of typographical errors in new editions of textbooks varies considerably from book to book. After some analysis, he concludes that the number of errors is Poisson distributed with a mean of 1.5 per 100 pages. The instructor randomly selects 100 pages of a new book. What is the probability that there are no typos? That is, the probability x is equal to 0, given that mu is equal to 1.5. Applying this into the formula gives p of 0, that is probably x is equal to 0, is equal to the minus mu times mu to the x over x factorial, which is e to the minus 1.5. Mu is 1.5 times 1.5 to the 0, x is equal to 0 over 0 factorial. 0 factorial is 1. This works out to be 0.2231. That is, there is about a 22% chance of finding 0 errors. As mentioned on the Poisson experiment slide, the probability of success is proportional to the size of the interval. Thus, knowing an error rate of 1.5 typos per 100 pages, we can determine a mean value for a 400-page book as mu equals 1.5 times 4, which is 6 typos per 400 pages. So for a 400-page book, what is the probability that there are no typos? That is, the probability that x is equal to 0 is equal to the probability of 0 is equal to e to the minus mu times mu to the x over x factorial. Here mu is 6, that is 6 per 400 pages. So e to the minus 6 times 6 to the 0 over 0 factorial. Remember, anything to the 0 is 1 and 0 factorial is 1. So you're looking up e to the minus 6. This gives 0.002479. So there's a very, very small chance that there are no typos. For 400-page book, what is the probability that there are few, 5 or less, there should be 5 or fewer typos? Since it's countable or discrete, you would use fewer instead of less. Okay, the probability that x is less than or equal to 5 is obtained by summing the probabilities that x is equal to 0, 1, 2, and including 5. So these probabilities, using the formulae for each value of x, gives you a lot of work. This is rather tedious to solve manually. A better alternative is to refer to table 2, again in appendix B, in the text, table 2 in appendix B, where k is equal to 5, mu is equal to 6, and the probability that x is less than or equal to k is equal to 0.446, read directly from the table. So that is, there is about a 45% chance that there are 5 or fewer typos. Again, there's even a better alternative. Excel using evoking the function Poisson, evoking the function Poisson, brings up this window where you fill in the values accordingly. X is equal to 5, the mean mu is equal to 6, and you accumulate in the probability x is less than or equal to 5. You put true here because you're accumulating. And the result is 0.4567961. That's obtaining the probability. That takes everything